Alrighty, hi everyone, my name is Emily, and I'm just going to be moving right along into the next figure of our paper. So the question they were asking for figure 5 is, what occurs as a result of base 1 accumulation in the GGA3 deletion neurons? So here in figure 5a, we are looking at still images of a movie, and this is in base 1M cherry neurons. The neurons either have GGA3 or GGA3 deletion, and they wanted to look at how base 1 accumulates. So as you can see pointed out by the white arrowheads in these bottom two images, those are the axonal swellings of base 1 accumulation. And then on the bottom, they quantified these by looking at the linear density of the base 1 positive swellings, and then also the percentage of neurons with swellings and neurons without swellings. As you can see in both of these two cases, the linear density in the GGA3 deletion neurons is significantly higher than the neurons with GGA3, and then the percentage of neurons with swellings is significantly higher in the GGA3 deletion neurons, and they found that it was about 90% of these neurons had axonal swellings. So overall, they were finding that the overexpression of base in the GGA3 neurons exhibits more axonal dystrophies. And then in figure 5b, instead of the base 1M cherry, we're looking at synaptophysin overexpression and how it influences axonal dystrophy. Once again, they were looking at the linear density and the percentage of swellings. And the only case in which there was a change in the axons was when there was base 1 overexpression in conjunction with GGA3 deletion. And then if you see in that image right here, the bottom with the white arrowheads, those again are the axonal swellings. And like I mentioned, these two images were, for figure 5A and 5B, those were still images of a movie, so I'm just going to show you guys the movie to help you visualize. So right here at figure 3A, the white arrowhead is pointing towards the vesicles movement throughout the axon, and here they described it as in the GGA3 deletion neurons, they're making, quote, like bouncy movements, the trapped vesicles are. And then now figure 3B, it's a comparison of the base 1M cherry to the synaptophysin neurons. And now figure 5C, here we are looking at the cerebellum of mice, once again with that either have GGA3 or there is a GGA3 deletion. Now, specifically in the cerebellum, we're looking at the Purkinje cell bodies. They wanted to look at these ones because they know that their axons are capable of regenerating, and it's also been previously found that base 1 expression occurs in Purkinje cells. So in the 4-month-old mice, as you can see on the left, there are no axonal swellings, but on the right, which they have outlined in a square, and then these are the enlarged images on the bottom right, the white arrowheads are pointing towards the axonal spheroids, which are the axonal swellings of base 1 accumulation. And then on the left, they also quantified the swelling density. And once again, as you can see, the GGA3 deletion neurons have a higher swelling density. And then for figure 5D, similar to the one before, but instead of looking at the cerebellum, we're now looking at the axonal morphologies in the hippocampus of 4-month-old mice. And once again, we're comparing mice that either have GGA3 or there's a GGA3 deletion. Now what they found was that the axons that are populating the CA1 area, they were exhibiting alterations, fragmentation, and spheroids. And it's a little hard to see, but on the bottom right, the enlarged image of the hippocampus of the GGA3 deletion mice, there are white arrowheads that are pointing towards the axonal swellings. And then along with looking at the swellings, they also measured the axonal density, as you can see on the top right with this graph, and they found that around 25% there was a reduction of about 25% in the GGA3 deletion mice in comparison to the wild type mice. So they now know that there's a loss of axonal density, specifically in this region. So now that we know that GGA3 deletion results in axonal swellings and base 1 accumulation, they wanted to ask the question, how do other substrates influence base 1 accumulation? So in figure 6, similar to before, we're looking at base 1 M-cherry expressing neurons, which are either have GGA3 or there's a GGA3 deletion, and they wanted to see, once again, the base positive swellings. Now, along with this, they also either reintroduced GGA3 or they gave the neurons a gamma or beta secretase inhibitor. In this case, C3 is the beta secretase inhibitor and DAPT is the gamma secretase inhibitor. Now, when comparing the neurons in these different conditions, we can see that in the case of just the GGA3 deletion neurons, we are having, once again, base accumulation with a higher linear density and a higher percentage of neurons with swellings. But in the neurons with the GGA3 reintroduction, it's returning to the endogenous levels. And then we're also seeing the same happen in both the GGA3 deletion neurons, but have had either beta secretase or gamma secretase inhibited. And then once again, that white arrowhead is pointing towards the base spheroid. So overall, what we're seeing is that the inhibition of beta or gamma secretase is preventing axonal dystrophies, and it's influencing the levels of the base 1 positive swellings to return to levels seen in mice which originally have GGA3. So now with the same experimental setup as before, but instead of the stills of the movies, we're now looking at the chymographs of the base 1 M-cherry particles to analyze the base 1 axonal mobility for both the anterograde and the retrograde movement. So now looking at the chymographs, you can see there is motility and movement, both anterograde and retrograde, in the cells with the GGA3. And then with GGA3 deletion alone, there is much more stationary, there is not as much movement. And then, interestingly enough, with the reintroduction of GGA3 to the GGA3 deletion cells, we see that the reintroduction is capable of restoring the base 1 trafficking. However, as you can see, this is just for restoring the retrograde movement, so towards the cell body, but the reintroduction of GGA3 was not capable of rescuing the anterograde vesicles. And then moving on to GGA3 null with the beta secretase inhibitor. This also is capable of rescuing motility, as they showed fewer stationary base 1 positive vesicles than just the GGA3 null neurons alone. And then the same findings were true with the DAPT treatment of the gamma secretase inhibitor. So what these findings also confirm for them are the previous findings that GGA3 is a primarily retrograde targeted protein. And then moving on to a supplementary figure, here we're looking at a base 1 M-cherry neuron that has GGA3 deletion, and then a GFP GGA3 neuron. The base 1 M-cherry neuron has had a reintroduction of GGA3. So what this is showing is just to further drive home the point that the inhibition of beta or gamma secretase has the same protective effect as reintroducing GGA3, as seen by the reduction in axonal swellings. And then for the second part of figure 6, a little different from before, here we are looking at mice that either have GGA3 or GGA3 deletion, and they wanted to test how BACE inhibition would impact the axonal dystrophies in the GGA3 neurons. So the way that they did this was they took 2-month-old mice and they fed them a diet with either a control diet, so no BACE inhibitor in it, or a diet with MBI, which is a Merck BACE inhibitor. And they also gave them differing levels of the BACE inhibitor. They either give them 3, 10, or 30 milligrams per kilograms per day, so just to test the range of BACE inhibition. And then as their pharmacodynamic biomarker, they were measuring the A beta of 40. And what they saw, as you can see in these graphs here, that all 3 of the doses that were being given to the GGA3 null mice were capable of preventing Purkinje cells, if you recall, those were the cells in the cerebellum, from swelling. However, in the hippocampus, on the graph on the right, so CA1, they saw that only the highest dose was capable of restoring capable of producing a similar axonal density as the mice which had GGA3. And then here is just some statistical analysis of the different experiments. As you can see, with the increase in BACE inhibitor, we see an increase in the axonal density in the CA1 region. And then we also see a reduction in the swelling density dependent on the dose.